All right, so here we are, 1.3, the second section, the second part of chapter 1. And so what we're going to be focused on here today is surface area. So you should have your notes in front of you for 1.3 there. And let's take a look at this first page. The first page on your notes talks about this, what you'll learn. So what we're going to be learning is finding the surface area of composite objects. Now, we'll talk a lot about that in the upcoming classes, but let's just focus in on a couple words here first. Surface area, okay? If you have some kind of object, and thank you, and I'm going to just, this stack of sticky notes here, this is a rectangular, because the face is a rectangle, and it's a prism, it's got depth, a rectangular prism. And if I hold it really tightly, it's got all right angles on the corners, are all right angles to each other. So it's a right rectangular prism. And if we're wanting to find the surface area of this object, we would literally add up the areas of all of the sides. The top side, the bottom side, this side, this side, this side, and this side. That's 6 sides for a rectangular prism. And we would find the surface area, or the area of each rectangle, and we just add them all up. So that's the total surface area. Now, composite objects, think of the word composed, okay? If something is composed of this and this and this, that means it's made up of different parts, okay? Or think about the word, you may have heard the word composition, okay? What's the composition of this material? Like, in science, we would say, what's the composition of this right here? Well, we've got metal parts, we've got plastic parts, we've got a little bit of rubber on the bottom. The composition of it is what it's made of, the different things that makes up the whole, okay? So composite object would be different 3D objects almost like stuck together, okay? So if you think of some kind of, some kind of robot, okay? So you've got a big, rectangular prism for a body. You've maybe got, cylinders for arms, okay? And you've got a big sphere, a circle, a 3-dimensional, sphere for a head, and so on. And, you've got another, maybe a trapezoidal prism or whatever here. And then you've got, for some reason, you've got maybe triangular legs, okay? Triangular prism here for legs or whatever. You know what I mean? So this would be a composite object made of, 1, 2, 3, 4, 5, and so on. Different things all stuck together. And finding the surface area of a composite object gets a little more complicated because, again, we stick things on top or on the side of other things. And when we stick them on, we cover up some of the surface area of both of those objects. Okay, but we'll get to that. That's going to be a little bit later. So surface area and composite objects are going to be our terms right here, surface area, composite object. Those are the terms that I've just introed a little bit, the meanings of those, and we'll talk about those a little bit as we go on. If you have any notes here for this first page, you can put them, anything you want to put on your cue card while we go. Just flip back to the first page and just write it down. Like, formulas for, for a sphere, formula for a sphere, or whatever. There'll be things like that onto your cue card that you'll study from. All right, next page. Okay, we're starting officially 1.3 here. And in your textbook, Pearson Math Makes Sense, Math 9, we're on page, the start of 1.3 starts on page 25, okay, in your textbook, if you wanted to go there. All right, so surface areas. Find the area. Let's just talk about 2-dimensional shapes, one at a time. Let's talk about areas for shapes. We need to remember what the formulas are for areas of certain shapes. And you may remember this, but some might be a little tricky, like a square, a triangle. I don't know. Let's see if you remember them. So what shape, first of all, is this on the left? What shape is that? That looks like a square, and I'm going to give you some more information. I'm going to do this. Now, I don't know if you see that in the back, but what am I doing? What did I do there? I put little marks on each side. I put one little tick mark on each of the sides there. So what does that mean? Yeah.
That all the sides are equal.
That means that all the sides are equal length, okay? Now, if I did this, don't do this, but if I did this, that means that only these two sides would be the same length because they have the same mark. And then these two sides would be the same length but different from the first two. And don't write this down, but that would be something like maybe 4.5 or something. You see how they're different. So these two would be the same, and then separately, these two would be the same. So if any side that has an identical mark, like 1 tick or 2 ticks or 3 or whatever, if they have identical marks, they're identical in length, okay? So now I'm gonna go back and erase a bunch of this stuff, go back to our original, there we go, okay, come on. Ow, almost had it. Big thick eraser there, okay. So this means that all the sides are equal and all the sides are length of 5. There's no units on this, so we'll just, at the end, we'll just say units squared. Like we'll have to make up just units. If there's no units given, that's what you do. I'll show you that. So what's the area for a square? What's the formula for the area of a square? Anybody?
Length times height.
Okay, length times height. Okay. So in a rectangle, we usually do length times width. In a square, you can still do length times width. The length and the width are the same, so sometimes we use the same letter for all sides. So you could do length squared, you could do width squared, or you could do just the side length squared. And you'll see that, I think, most often in math textbooks where it's like the side length, S, squared. But you could do length times length or length squared. You could do width times width or width squared. So it's basically just whatever one side is, and you square it. Now, why do you square it? Because the area of a rectangle is the same as an area of a square, and you do length times width. So because the length and width are the same, that's why we square just the one number. So the area of a square is just the side length squared. So the area of this square is going to be 5 squared. What is that when I simplify it? 25. All right. Now, before I finish here, this is an area, so the units for area are always the length of the side, whatever units those are, and then you put a little squared as an exponent there. So the units for area would be units squared. If this was 5 centimeters, and this was 5 centimeters, then this would be centimeters squared, okay? So think about area that covers an area as squared. There are 2 dimensions we're multiplying, so really, this should be fairly straightforward. Look at this, centimeters times centimeters. I'm multiplying centimeters by themselves twice. So that's centimeters times centimeters, or centimeters squared. So there's a reason why area units are squared. Now, going back to the original, if you wrote down centimeters, then that's fine. But going back to our original situation, if we have just no units shown, then we don't know what the units are. What you would do is you would literally write u squared. So whatever the units are squared, okay? So I am going to require you to practice putting your units on all of your answers. And for area, it's always units squared, okay? Or centimeters squared, or meters squared, or kilometers squared, or micrometers squared, or whatever. It's always squared. All right. Okay, I know we're going a little slow here, but I want to make sure that everybody gets it. Okay, next. Why don't you put numbers like this, 7 and 3, okay? 7 and 3. So what shape is this? Yeah, this is a rectangle. It's not a square because all the sides are not equal. So this is a rectangle. Okay. What's the area formula for a rectangle? Yeah, we mentioned that before. So it's going to be length times width. The length is usually the longer side. The width is usually the shorter side. But technically, it doesn't matter which one you apply to the width. It doesn't matter. But usually, we say the long side is the length. So the area for this particular rectangle would be the length of 7 units times the width of 3. It really doesn't get too much easier than this. This is 21, and I don't know what the units are, so we'll say units squared again for this. Okay. Everybody got that? Okay, this is terribly easy, isn't it? Is this like almost, I'm almost insulting you how easy this is, right? I promise we'll get a little tougher here. Okay, so a circle. This one is a circle, okay? So what's the area formula for a circle? Who remembers that? Sorry?
Diameter times pi.
Diameter times pi. Not quite. That is not the area formula. That actually is the circumference formula, so you're very close. Anybody want to adjust that?
Is it
Radius times? Radius times pi? Not quite, but you're getting very, very close. It is pi times radius squared. So very close to 2 pi r, which is pi d. But so the area of a circle is pi r squared. Now what is r in the circle? Do you know? What is r? Okay, so r is the radius. Yeah, r is radius. And that radius is the distance between the very center of the circle to the outside edge. Okay, whatever that is. Now this just disappeared on me, but this is 10. And I'm going to say this is 10 millimeters, guys. I'm going to say it's 10 millimeters. So why don't you add a unit there? We'll go 10 millimeters, which is the radius. So r here is 10 millimeters. So the area of this circle is going to be, now what is pi, by the way? Okay, you remember pi, 3.14. It's actually an irrational number, which means that the decimal goes on forever and ever and never stops and never repeats. It's not a rational number that can be written as a ratio of two integers. It's irrational. So it's a special number, and pi is a special, let's say, characteristic of all perfect circles. So if you were to draw a perfect circle, pi, this special number, would be part of calculating its area, no matter how big it is. It would also be part of calculating its circumference, or the perimeter, which is also called the circumference, the perimeter of the circle. So every perfect circle, okay, this is a perfect circle. Every perfect circle, I could measure the distance from the middle to the outside, the radius. I could multiply the radius times itself and multiply by pi and get the exact amount of area that this covers. So pi is a very special, important part of every perfect circle, which is amazing, actually, that there's this some number out there that is a characteristic of physical things. And that's part of math, which I really love. Math is very intangible. It's a abstract concept, but it has connection with real world things. I think that's amazing, and
that was easy.
And it's easy too, okay? My easy button. I don't remember to hit that button enough, but when we do a problem and then we're done, I should remember to hit the easy button, shouldn't I? Yes, okay. Unless it's hard? Yeah, I should have a hard button too. Like, that was hard. But there's just so many questions in math that are easy, so that's why they make an easy button, you know? Okay. You guys doing okay? Am I doing okay? All right then. Okay, so pi, now I really, really don't want you to use the number 3.14. And I know that's probably what you did in elementary school, right? I want you to use your pi button on your calculator, okay? So we're able to use our calculators for this. That's totally fine. You should use your pi button. Now, if you do not have a calculator, or you don't have a scientific calculator that doesn't have pi on it for some reason, you should have a scientific calculator in high school, but you can use this number. This would be acceptable, 3.14159. Okay, go to 5 decimal places. That's easy to remember. But you should use the whole decimal, which is the pi button on your calculator. So let me show you. On my calculator here, which should be coming up. Oh, here it is. On my big fancy TI-83 calculator, if you have a scientific calculator, you should have a pi button. Looks like I have 2. What the what? Okay, exit. You should have a pi button if you have a scientific calculator. And for me, the pi button is right here. It's a second function. And this is actually the exponent button. This little hat on mine, it's the exponent to the power of. So pi is the second function. All right, now let's turn this on. Why do I have so much stuff there? Oh, I don't know. Okay, so check this out. Second function pi. If I hit equals, So you see it gives me as many of the decimals that can fit on the screen here. So that's what pi is, 3.14. And if you don't have a pi button, then you can use 3.14159. That'll get you pretty close to an accurate, precise number. But you should use your pi button when calculating this. So let's go back to the drawing board here. Pi times the radius, or 10, squared. So on your calculator, let's do that. Let's do pi, and then you can do times if you want, or you can just use the brackets, which your calculator will know you're doing multiplying, times 10 squared. You should have a squared button. And you know that that's 100, so you can just go ahead and type 100 in too, because 10 times 10 is 100, you should know that. Right? Because this chapter, we learned. So let's hit equals, and we get a decimal number, of course, because we've got pi in there. But we just moved the decimal place from the pi number over twice. That's what times 100 means. Move the decimal to the right 2 times. So 314.159. Let's do that. 314.159. And that's going to be a decimal approximation of this area to 3 decimal places. And what are the units that I should put on this?
Millimeters.
Millimeters. Thank you. Squared. Who said squared? Millimeters squared. Thank you. Don't forget the squared. Right? It's an area. Why is it squared? Because look at what we did up here. We did 10 millimeters times 10 millimeters. That's what we actually did. So I've got millimeters times millimeters in my answer. That's millimeters squared. All area calculations should have a square unit of length in the answer. Okay. How's that? Good? All right. Make sure you remember the area for a circle. Area equals pi r squared. Excellent. Okay. Now what happens if I have a circle with a radius of 47 over 3? Oh, it's a nasty fraction, isn't it? Can we still do it? Yeah, we sure can. We sure can. Let's do that then. So remember, the radius is the distance here from the center to the outside edge, and it's the same to any part of the outside edge. Doesn't matter. So this radius is 47 over 3. Just out of curiosity, what's the diameter? What's the diameter for this circle? That is the distance all the way across. If you think about it, it's 2 radius, or 2 radii, 2 radiuses. So what's the diameter here? How do I multiply 47 over 3 times 2? Anybody remember what the easy way to do that is? Oh, that's actually, with this one's not an easy thing to do. But if I multiply this by 2, 2 times 47 over 3, right? So what's that going to be? 94 over 3. Okay. Yeah. So that's going to be the diameter. Now, if you were given the diameter only, and you were asked for the area, we're not given the radius, but could you do it?
Yeah.
Yeah. All you'd have to do is divide by 2, right? Now, this may be a little challenging for some of you, but how do we divide a fraction by 2? Divide by 2. Ooh, that's tough. Remember, that's the same as what? Multiplying by the reciprocal. What's the reciprocal of 2? 1 over 2. Yeah, the reciprocal of 2 is 1/2. So when you divide a fraction by 2, it's the same as multiplying by 1/2. So D is equal to 94 over 3 times 2 is 6, which reduces to 47 over 3. See that? So that's a bit of a challenging one with the fraction there. But if you're given the diameter, just divide it by 2, and that's going to be your radius. Because the radius is what you need for calculating area. Okay? All right, so I'm going to just make some space here. I'm going to put that radius back up. Okay, is everybody clear on the relationship between diameter and radius there? Hopefully. All right, so area is pi r squared for a circle. Area is, oh, what's the units for this? Let's make them, somebody give me a unit for this radius. What do you think it should be?
Meters.
Meters? Okay, meters. What is 47 divided by 3 as a fraction? Anybody know what that's close to? Okay, it's close to 16. Yeah, 16 meters. What would be a circle that has a radius of 16 meters? How big is that? What would that be? 16 meters for a radius.
That's huge.
That's pretty huge, yeah. That's pretty close to like a baseball infield or something. Right? From the pitcher's mound to first base, pretty close to 16 meters. So what's that? 90 feet divided by 3. 90 feet divided by 3 is 30 meters. So 30 meters from home plate to first base. 90 feet. Is that right? So, yeah, 16. Pretty close. It'd be a little bit smaller than a baseball field, maybe. Okay, anyways. Just getting our bearings here. It's definitely not this room, right? The radius of this room would be about what? What do you think? What's the estimate for the radius of this room? 5 meters? 6 meters? Here's a meter stick right here. Am I about in the middle of the room right here? Probably. Okay. So I'm going to go, that's 1. I'm going to go 2. And I'm going to go about 3. About 3 meters. So 6 meters diameter, if this was a circle, this room, 3 meters radius. Does that make sense? Yeah. All right, so there you go, just so you have an idea of length of things. Okay. So pi, we'll use our pi button on our calculator, and I'm going to go 47 over 3 squared. That's like going 47 over 3 times 47 over 3. Let's try and do this in fraction form. Let's leave our answer in fraction form, because it's easy to just pump this in the calculator, write a decimal, round it off, done. Let's see if we can working with this in fraction form. So what's 47 times 47? These are some big numbers here. Are you guys ready for this? I think you are. 47 times 47 is 47 squared. That is 2209. 2209. What's 3 squared? Is 9. Pi. Okay. Now, can we reduce this, do you think? So what we're asking is, can we divide the top and the bottom by the same number and get a whole number as an answer? Yeah. So that's not 1, right? So can we divide both of them by 3? Well, 9 only has a few factors. It's 1, 9, and 3, right? So we could divide 2209 by 9 and see if we get an actual number there. So let's see if we can reduce that. Let's divide that by 9 and we get a decimal. Okay, so we can't reduce it that way. What if we did 2209 divided by 3? Now that's a decimal too. So I don't think we can actually reduce this fraction. Does that make sense? Some of you might have a calculator that can do that for you. So watch this. 2209 divided by 9 equals. Now I have on this calculator, I have a function that says 2 fraction. And you should have a fraction button on your calculator that might be able to turn a decimal into a fraction. I don't know. Every calculator is a bit different. But I'm going to do this one, and I'm going to see if this will work. Okay, it gives us our original fraction, which means that this is the most reduced version of this number. Okay? So there is a little lesson in working with fractions, but this would be the entire answer for this area if the radius was 47 over 3 meters. And this is in exact form. Now you won't have to worry too much about exact form versus approximate form in grade 9, but I'm teaching calculus later today, and that's very important. So when you get to grade 12, you're going to have to be an expert on working with fractions like this. So I want to just give you a little heads up there now. Okay? All right. Any questions? Was that too tough? Last one? No. Not too bad? You guys understood it? All right, let's turn our attention towards triangles now. Triangles. Okay? Triangles are 3-sided figures, closed figures, 3 straight sides. One can't be curvy. That doesn't count. 3 straight sides. This one looks like it might be a right angle right here. It might be a 90-degree angle there, so it might be a right triangle. We don't know that for sure. But luckily for area, it doesn't matter if it's a right triangle or not. But what we do need to know is we need to know the height. So because we're given this side length as 3, I'm going to tell you that this is a 90-degree angle, so you can put that 90 there. Because the height of the triangle will now be 3. Okay, that's the height of the triangle. And this 7 is the length of the base of the triangle. So who remembers what the formula is for area of a triangle? Anybody remember that? Let me give it a try. If you're wrong, that's totally okay.
Base times height divided by 2.
Base times height divided by 2 is absolutely correct. Yes. So there's 2 different ways you could show that, and I'll show you both different ways. You could do exactly what you said, base times height divided by 2. Perfect. You could also write it like this, 1/2 times base times height. And to tell you the truth, as you move through math, you'll probably see it a little bit more like this than you will like this. Okay? You'll see that half in front. But both of them are correct, and whichever one you decide to use is totally fine. All right. So the base here is which number? Well, I kind of give you a hint there. If it's a right triangle, though, this one obviously looks like it's the base because it's on the bottom, right? If we were building a structure or something, the base would be what's on the bottom. So viewing it this way, that looks like the base. And this looks like the height. And that's totally true. But watch this. In a right triangle, okay, in a right triangle, I'm going to tip this triangle over a bit. I'm going to tip this triangle over where I have 7 here and 3 here. So I'm just like bringing this up, and this is going to go down to the ground, you see? So this is the same triangle. And now it looks like 3 is the base and 7 is the height. Am I going to get a different answer if I look at the triangle that way? You know what? You're right. I'm not going to get a different answer because multiplication is a word, it's called commutative. Multiplication, you can do A times B, but you can switch them around and do B times A and you'll get the same answer. So if you think about commuting, going back and forth from work, that's a word maybe you've heard, commute to work, back and forth. So multiplication, you can do 3 times 7, and that'll be the exact same answer as 7 times 3. So it doesn't matter which way you look at this triangle. If it's a right triangle. Over here, on the second example, you will see that this 5 has to be the height, and that's a bit of a different situation, okay? But we'll get to that in a second. All right, so let's go ahead and do this. I'm going to erase this so I have a little more room to work, and this as well. So the area here, I'm not given any units here, so that's okay. I'll just do units squared when I'm done, is going to be the base, which is 7, times the height, which is 3, divided by 2. Area is, let's give this answer both in decimal form and in fraction form. Let's do that. Decimal form first. 21 over 2 is equal to what?
10.5.
That is very good. It's 10.5, and I'm not given any units, so I'm going to go units squared. Awesome. If I asked you to write this in fraction form, area is, what's this in reduced fraction form? 21 over 2. Can you reduce that any further? No, you can't. So right, 21 over 2 is our reduced fraction form. Very good. Remember, reduced fraction form, there's no common factors on the top and bottom, so you can't divide both numbers by the same thing and get another like set of whole numbers or integers. And there's no decimals in a fraction. You can't have any decimals in a fraction, so you couldn't go 10.5 over 1. That's simplified. That's not a simplified fraction. This would be the simplified fraction, okay? That's the decimal. Good? All right, let's do one more example here with the triangle. Notice that this is not a right triangle, but the area formula is still the same. Let's use the other one here now that looks kind of like this. 1/2 base times height. Exact same as the one we used before. So in this case, the base is 4, and the height is 5. Okay? And I would encourage you to make sure that you treat 4 as B and 5 as H. Even though if we have a base and a height, as I mentioned before, it doesn't matter which order you multiply them in. They're going to be the same product every time. But just so that in future, let's say we had something like this. This was 6. You have to be careful that you don't include 6 as the base or the height. That you can't use that one, because this is a side length. It's neither the base nor the height. So this is the base and this is the height. So you got to be careful if you're given extra information there. Just please note. And okay, I'll finish this example. So area here, I'll change colors. Area is 1/2, the base is 4, and the height is 5. Okay? Now, order of operations say you can just multiply all those 3 together left to right as you see them. So you could do 2 things. You could do 1/2 times 4 first, which is 2, and then times 5 to get 10. Or you can just go 4 times 5, which is 20, times 1/2, which is 10. So multiplying 3 or more numbers together, it really doesn't matter which order you do them, whichever is easiest in your mind. If it's all multiplication, whichever is easiest. Okay? So 10, no units given. That's going to be units squared, isn't it? So do you have to put your units for your answers here? Yes, you do. Is it always squared for area? Yes, it is. Okay, very good. If you know that, you're golden. Yes, volume is cubed units. That's exactly right, cubed, so to the power of 3. Length is just to the power of 1. Area is to the power of 2. And volume is to the power of 3, because we do length times width times a third dimension height to get volume. So that's why it's cubed. Very good. Let's take some time to write some formulas for area. You have them in your notes there. Let's put them all in one spot and see if we can even remember what they are. So the area of a square is side length squared, right? So just the length of the side squared. What's the area of a rectangle? It's length times width, so the 2 dimensions. Perfect. What's the next one? The area of a circle. Pi times radius squared. Very good. And the area of a triangle. Right, so base times height, let's do that one, divided by 2. Or I'll put another equal sign here because it's also equal to 1/2 base times height. Okay. Very good. Now, these 3 are pretty straightforward, but the triangle, I would like to just remind you that in a right triangle, this is a right triangle, that this is the base and this is the height. The side length also is the height. In a non-right triangle, so this one right here, okay? If this is the base, then the height is the distance, like the overall height of this triangle. So it's the distance from the opposite vertex, from B, straight down to the base, forming a 90-degree angle. So let me just take a moment and talk to you about that. This would be the height right here, if this is the base. The base and the height always have to form a 90-degree angle, okay? The base and the height always have to form a 90-degree angle. So this is a non-right triangle. Okay? So okay, let me give you you don't have to write this down, but let me just give you a little test here. Okay? This is like a little practice here. So I'm going to draw a triangle with that, and that. This is going to be A, this is going to be B, this is going to be C. Okay? Now, if this is the base of this triangle, right here, what's the height? Okay, I have a lot of you saying A. Okay, think about this triangle, and I want you to tip it on its side. So B is on the bottom. Which is the one that forms the 90 degree with the base and represents the overall height? It's C. It's C. Very good. So A looks like the height, but that's only if this is the base, see? Okay. All right. So good job if you said C. Now let me go back and let me say this is the base. Let's say this is the base. What would be the height in order to find the area? B. Right. This is the height then, you see? It's from the base, a 90 degree angle, all the way to the opposite vertex. Okay? One more exercise here. And you know what it's going to be. Oh, gosh. A. Okay, so if this is the base, then A is the height. It forms a 90 degree angle, touches that base side, and it goes to the opposite vertex. Okay, very good, very good. So this is what I'm going to do actually for today. I'm going to give you some area questions for you to do, just two-dimensional figures, because we're running out of time for this first lesson. We're going to stop kind of from our notes now. In your notebook, I don't think you have space for this in your notes. In your notebook, please write down these 5 questions. Okay, so here's your assignment for today. Everyone should have this written down. Yes, you can be dismissed if you have these written down. Here's question 1 and 2. Answer should be in decimal and fraction form. Give me 1 second. Here's questions 3 and 4. Find the area of those. And question 5, here's a right triangle with 3 sides given. Find the area of this right triangle. That's your assignment for today. Oh.